Okay, so we'll do the fourth problem, which may be the last problem in this RZ transients. So in the circuit, the switch is closed on position one. Sorry, on position one at t equal to 0. After one time constant, it is moved to position 2. Find the current before and after moving to position 2, assuming no initial charge in the capacitor. So it is initially at position 1 at time t equal to 0. It is at position 1. It is not actually like in the previous problem, like t equal to infinity, which is steady state, but it is actually after one time constant, which is tau. Now for RC circuit, the tau value is capital R into capital C, or tau is equal to R into C. Okay, so we should not use t equal to infinity here to find the initial condition, but t equal to tau equal to RC, which we will see in the problem. Okay, so it is moved to position 2. Now the circuit is like this. So 100 volt source is there, and in position 1, and there is position 2 with another 100 volt but in the opposite polarity, and we have a resistor 50 ohm and then a capacitor 20 microfarad given. Now when the switch is in position 1, this will not come into picture, so the circuit is actually closed like this. So 100 volt and then 500 ohm followed by 20 microfarad. Now the circuit is in this condition until t equal to tau equal to RC for one time constant. So you have to find the value of time constant RC. So tau is equal to RC, the value of R is 500 and C is 20 10 to the power of minus 6. Substituting the values, we will get the after simplification we'll get 0.01 seconds. So after 0.01 seconds, I'm going to move the switch to position 2. Okay, so in the previous problem it was actually infinity. This value was supposed to be was calculated as infinity because I keep the switch in position 1 until steady state is reached, which is infinity. But here it is until t reaches 0.01 seconds. So voltage across the capacitor is V into 1 minus e power minus t by RC. So after one time constant, which is t equal to 0.01 seconds, the voltage across the capacitor will be the supply voltage 100 multiplied by 1 minus e power minus 0.01. So in place of t, it will become 0.01 divided by RC. Actually this RC and this RC are same, so I don't have to substitute the value at all because this is actually what RC. Okay, so RC by RC will become 1. So I substituted RC value to be again 0.01, so it is 1 minus e power minus 1. So it is 1 minus e power minus 1 is 0.632. Actually this will come to be 0.368. So 0.632 into 100 or 63.2 volt. So voltage across the capacitor after one time constant is 0.63.2 volt, which will be the initial condition for your switch in position 2. So if I move the switch to position 2, what will happen? I'll get this circuit, because the source voltage will be cut off and the switch will be moved to position 2. So this is your position 2. Now I'll assume the current direction to be I of t like this, and then 500 ohm. We have seen the initial voltage is 63.2 volt as we calculated after moving the switch to position 2. Okay, the initial condition 63.2 volt and the 20 microfarad in series. Okay, so initial voltage across the capacitor 63.2 volt. So applying Laplace, you will get 500 I of t plus 1 by 20 integration I of t dt is equal to, you have direction of current like this clockwise, so it is plus to minus 63.2, again it is plus to minus 100 volt. As I told you, you can directly use the value of R and C, 1 by C, and then do the calculation, finally substitute, or else directly substitute, but take care that it is 20 microfarad. Okay, so it is for 500 s plus 1 by 20 I of s by s is equal to minus 163.2 by s, taking Laplace. Okay, now after all the simplifications are done, I'll get minus 0.326 into 1 divided by s plus 1 by 1000. Taking inverse Laplace, minus 0.326 into e power minus 1 divided by 1000, but taking in care of the microfarad value, it is 10 to the power of minus 6 multiplied. So it is e power minus 100 t. After simplification, it will be e power minus 100 t. So I of t is minus 0.326 e power minus 100 t ampere. Thank you.